flip over here so I can get my formulas right as I'm looking. All right. So, blood bank catalogs the type of blood, including positive or negative Rh factor, given by donors during the last 5 days. These are people giving blood. You can have a positive or negative Rh factor, and then also all these different blood types. I, for example, am one of the most common blood types that's A positive. If you've ever given blood, you can find out your blood type, or if you've ever had blood taken at the hospital for any reason, or doctor's office, they can tell you your blood type. Something you should know if you're ever in an accident. Number of donors who each gave blood is shown in the thing. Donors selected at random. Okay, find the probability that they have type O or type A blood. Now, type AB blood is not also type A blood. These are all very different things. So type O blood is 184 people had type O blood out of 409. Remember, this is an OR question, so this plus this minus the overlap. And this is O, and this is A, and this is the overlap. All right, type A blood, there was 164 out of 409. Overlap, they are mutually exclusive. You cannot have somebody who is type A and type O blood at the same time. That is impossible. So if I add these together, I get 184 plus 164 is 348. And if I divide those two, because this time I've decided I want a decimal, it is 0.851. By the way, on the AP test, they usually want you to round to the third digit, so make sure that you start practicing that. Okay, find the probability that the donor has type B blood or is Rh negative. All right, so we got this plus this minus this, because it's an OR question. Type B blood is right here. That's 45 people out of 409 people. Rh negative blood was 65 people out of 409 people. But if you look here, we've got what? Type B and Rh negative. You see how we just counted those 8 twice? So that's my overlap. Oh, sorry, this was B. This is Rh negative, and this is the overlap. So that's 8 out of 409. So if I take 45 plus 65 minus 8, I get 102 out of 409. Remember, if this is too fast for you, you should be pausing. You do not have to keep up with my crazy pace. I'm just going fast because I don't have any students in front of me. Okay, and that's the end of 3.3. And now we're on to 3.4. Almost done with our crazy breakneck speed here. This is our last section that we're going to go this fast on. After today, we'll have a review for chapters 1 through 9, or 1 through 3, and a test on it. And then we're going to slow down, and it's going to feel a lot better. But right now we're trying to catch up on what we learned in Intro to Stats. And if you didn't take Intro to Stats, that is Jasmine and Michael and Zach, I'm so sorry that this is crazy. Probably everybody else feels like it's a little crazy too, but not as much as you do. So a permutation is an ordered arrangement of objects. This ordered, that is the word that matters the most for a permutation. Things are in order. We care about the order. Find the number of ways you can type in a 4-digit code with no digits repeated. Now, the reason why we care about the order with a code is if you're trying to get into your car with like a code, or you're trying to get into your phone with a PIN, it's not like if somebody's code is 4256 that you could type in 5246 and get in. These are two different numbers because order matters in a code PIN on your phone. Okay, I'm going to cross those out so you don't think that those are anything to do with anything. Find the number of ways you can type in a 4-digit code with no digits repeated. Okay, so this is this, 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 this. So no digits repeated, that was 10 times 9 times 8 times 7. Okay. I think we did this example before yesterday. Yep, 5,040, and by yesterday for me, I mean like 45 minutes ago or an hour ago. 5,040 different ways this can be done. Now, there's something called a factorial. And a factorial is, for example, if you have something like 5 factorial, it looks like a exclamation point right after that. And that's 5 times 4 times 3 times 2 times 1. It's like a countdown, but they are all multiplied together. So 5 times 4 times 3 times 2 times 1 is 120. That's what 5 factorial means. A permutation formula says that when you have n objects in your permutation and you're picking r of them, that formula is n factorial over r factorial and n minus r factorial. In this case, that would have been 10 factorial divided by, oops, no, I messed up. No r factorial here. I do not have any whiteout at home, and I'm very upset about it. Sorry, I gave the wrong formula for that. I did combinations instead. So it's n factorial divided by n minus r factorial. So if I had 10 digits to choose from, I cared about the order, that's why it's permutation, and I want to pick 4 of the digits, then I would divide by 10 minus 4 factorial, which is 6 factorial. And if you think about it, that would be like, where can I get some more space? I'll shift up here for a second. So 10 factorial divided by 6 factorial would be this on top, you don't have to write this down, just watch, then 6 factorial on the bottom, which would cancel out all of these numbers, see? And you're left just with that 10, 9, 8, 7, which is how we calculated example 5. So there are a few different ways you can do this. You can either do multiplying 10 times 9 times 8 times 7, which is easy in some cases, in other cases not so easy. Or you can do these factorial things. So if you hit 10 and then math over to probability, and then see that factorial one is the 4th one down. So that'd be 10 factorial divided by 6 factorial, math, probability factorial. It looks like we're really excited about a 10 divided by a 6, excited, and that equals 5,040, just like we thought right there. You can also type in 10 and then go again to math, probability, and go down to that NPR, and then it